Okay, so today we are covering section 3.4, working with combining like terms. So I'm going to start with a couple definitions with these things, or a main definition that we're going to need overall. We'll again go into our general idea and process for this, and then we'll go through some examples down below here and over on the whiteboard as well. So our main definition that we have, and this is the overarching one because we're told we're combining like terms. So we need to define what exactly is a term. This is an extraordinarily subtle but very, I think, important definition that we need to have for this particular section, for this chapter, and for all of math moving forward, really. So our definition of a term is a single number, variable, or the product of a number, call its coefficient, and one or more variables called its variable part. So terms are represented by addition or subtraction signs. They're separated by that. So a single term, we have some examples of this. It could just be x, it could be 2y, it could be negative 32xy, 100x to the ninth, y to the fourth z, negative 14ab cubed c to the seventh, etc. But again, notice with all of these, an individual term, it can be a single number, a variable, or the product of a number and one or more variables. So a term is a bunch of things that are multiplying together here. And we separate terms out by addition or subtraction, which we're going to see in some of the examples, and we might be seeing it already down below here. But we have this is a term, this is a term, this is a term, and so on. And again, we separate those out. We have the specific names for them or different parts of them. So the actual number portion of this is called the coefficient. So we'll look at negative 32. We'll get this here. Circle an example we'll look at. So we'll look at negative 32xy as an example. So the coefficient of that, i.e. the number that's in front of this thing, or the coefficient, is going to be negative 32. We are including the number and the sign when we are asked about the coefficient. If we're being asked about what is the variable part of this term that we are working with, it's just going to be the variables and their exponents listed. So it's just going to be xy. So we have the coefficient, which is just the number out front that's being multiplied. And then we have the variable part of the term, which is the variables and all of their exponents that go along with them respectively. So looking at the one right next to it, so we have the term 100 x to the ninth, y to the fourth, z. The coefficient of that term is 100, and the variable part of that term is x to the ninth, y to the fourth, z. Separating it out from the coefficient, it's just the number. The variable part is all the variables and their exponents. Okay? And it's very important that we know the distinction between those two because it's going to be coming up as we're working through and actually adding and subtracting, multiplying and dividing these things together. We're primarily going to work with addition and subtraction in this section, but it's still very important that we know the distinction between those all the same. So we go into the more specifics of what we're working with for this section, which is, okay, we're told that we are combining like terms. So what are some definitions of these things? So we're going to define our like and unlike terms. So like terms are terms that have identical variable parts to them. So again, this is where we absolutely need to be able to identify or correctly identify the variable parts of all of the terms that we may or may not be working with in a problem. So this means, again, to have like terms, the variable parts need to be identical. That means every single variable is the exact same. Every single exponent is the exact same. If there is any difference whatsoever in any part of the variable part of these terms, they're not like terms. And terms are unlike if their variable parts are not identical in even the slightest way possible. Can't have it. So like terms are extraordinarily picky. It is an all or nothing. Either everything is the exact same and therefore the like terms, or not everything is the exact same, which makes them unlike terms. Which means you can't do a lot of the stuff that we're going to be doing down here with them. Okay? So this section, it's extraordinarily picky with what we can or can't combine together. And it all comes back to our definition of like and unlike terms that we have here. So make sure we have this nailed down for ourselves because it's very, very important. So some of the other parts that come in with this, and just making a note of this because this sometimes shows up on the homework, on tests, as you will probably see it in future classes. You may need to rearrange variables to more easily identify if terms are like or unlike. Sometimes you may be having an instance where you are multiplying some variable terms together and maybe you get multiple variables that are showing up, and it's not inherently obvious that these things are like terms or not by how they are organized. So a couple quick examples of this. So if we're asked, okay, is 12abc squared a like term with 4c squared ab? So we're just looking at our first that we have here. And at face value, we say, okay, well, our definition of a like term means they have identical variable parts. And looking at it at face value this way, the variable parts are not the same. This one's abc squared, this one is c squared ab. They're not inherently identical like this. But this is a really nice part about having that property of, and it was the commutative property of multiplication. If everything is multiplying together, I can rearrange these things into any order that we want. So I'm just going to put this off to the side here. So this 4c squared ab, I could actually rewrite this thing into being 4. Oh, good Lord. I don't like this pen by comparison to the other one. So I have 4ab c squared. And now suddenly I'm looking at the variable part as it's written here, and the variable part as it's written here, the two things that I'm comparing, and saying, oh, abc squared, abc squared. Suddenly, the variable parts are identical to one another, just having to rearrange them. I'm not changing the term, I'm just rearranging the variables. And now I know I've got like terms here. So those properties that we went through at the very beginning of this chapter, they are going to be coming back, and they will be useful, especially when we're, again, trying to identify if I have like terms, unlike terms, what we can or can't add together. So rearranging the variable parts of these terms can be very handy this entire section. I have another example over here that we can go through, and again, we would just be rearranging the variables to the order that we would need to see if these things are like terms. The general rule of thumb, if you are asking yourself, okay, well, how do is there kind of a standard way that I could always rearrange the variables to see if I have like terms or not? And the general rule of thumb, if you are going to rearrange the variable parts of terms, generally then you want to organize them in alphabetical order. So looking at our first one, this one had C's, A's, then B's. Yeah, just put it into ABCs. Make sure you keep the exponents with their respective variables, but otherwise it's really standard and expected that if you're going to rearrange these, put them into alphabetical order with their exponents still attached to them. Keeps it really standardized. We all know the alphabet, and we can go through and compare it that way. It's a bit easier to do that. Okay? So look at our next part. If the terms are like terms, so if we rearrange these things, we determine I have a like term here and I have a like term there. Great. Then the coefficients, specifically the coefficients, can be added or subtracted together as if they were normal numbers. The variable part does not change at all when you are adding or subtracting like terms. This gets a lot of people to say, okay, well, I've got a 4abc squared. Maybe I'm adding 12abc squared. Say, okay, well, I'm going to add the numbers together. I'm going to add 12 and 4. And then I'm going to add a, and then b and b, and then c squared and c squared. And we can't do that. The variable part does not change at all. It stays the exact same when we are adding or subtracting terms together. All that is adding or subtracting, all that is changing is the coefficient, the number out front. So the variable parts stay the same. The coefficients are the only parts that are changing if we can combine like terms. And again, I can't emphasize that enough because that gets a lot of people. Is we combine the coefficients together and then we think, well, I also combine the variable parts together. I've seen some people add exponents together. I've seen people multiply exponents together. Nothing changes with the variable part at all. It stays the exact same. Okay. So we're going to go through a couple of examples of this. What does this look like? How do we work with it? Different strategies that we have to work through these problems. So we're going to go through, and these are the examples that I'm going to be referencing. So 1 through 6 over here. We're going to jump on over to the whiteboard, and we'll go through and look at some of these as examples using our new stuff that we have here. So we'll jump on over there now. Whiteboard. Okay. All right. So our first example that we have here. Oops. And again, we're told with these problems, we're told to simplify the following, which that should be your buzzword. Think to yourself, told to simplify, what are we going to be doing? It starts with P. It ends in MDOS. So we're using PEMDAS for this thing. And again, that's our go-to. What am I starting with? What am I doing first? What am I doing second? PEMDAS is your guide if you don't know where to go or where to start this. So our first example that we have, told to simplify the following, and we are given 44x minus 9xy plus 10x plus 3xy. Okay, so we're looking to simplify these things, so combine like terms as necessary. I don't have any parentheses, I don't have any exponents, I don't have any multiplication or division going on, I just have addition, subtraction. This is the main part with combining like terms, or mainly doing addition, subtraction with this. So, couple strategies you can go through for solving these things. First and foremost, we want to find like terms to add together. And again, if we are trying to have like terms, that means the variable part of each of these terms needs to be 100% identical to one another to combine them. So looking at the example that we have here, I have an x term, an xy term, an x term, and an xy term. So we have two different types here. Now you have a couple options on how you could go through and organize this for yourself. One of the options you have is to take the original problem, identify some like terms, rearrange the original expression so like terms are next to each other, and then add things together. So I'm going to go through that one, which is, again, optional if you wanted to do that, but all we're doing here is we're just going to rearrange these things. So if we have this thing rearranged, I'm seeing, okay, I've got a 4x, or I got an x term, I should say, and an x term here. So I'm going to rewrite those to be next to each other. I'm not solving for anything. I'm just reorganizing the problem. When we are doing this, make sure you are keeping the sign in front the exact same. All we're doing is reorganizing this is all. Okay. So I just worked with my rearranging my x terms together. And now I'm noticing, okay, I have xy terms. So I'm going to put the xy's together. And again, this is just an optional rearranging step. Oops. I think this is a better 9. Okay. And now as we're looking at it, we're seeing in our first part here, we're seeing, okay, so I have both of my x terms right next to each other. I can combine these things together because the variable parts of these terms are the exact same. They're just x. So when the variable parts are the exact same, all that's going to happen is the coefficients, the numbers out front, those are just going to add together. Nothing else changes. So I have 44 plus 10. It's going to give me 54, and the variable stays the same. For the last part, I have an xy term and an xy term. So I'm just going to add the coefficients together. I have negative 9 plus 3. That's going to give me a negative 6. And then just bring the variable parts down. And we're good to go there. We can't do any other operations at that point in time, so we have our final answer of 54x minus 6xy. And like we went through yesterday when we're simplifying algebraic expressions, we're totally fine leaving our answer just like this. There's quite literally nothing else we can do to solve this thing. It's impossible to get a purely numerical answer coming out of this. So we'll take a look at our second example that we have here. So the second example that we have listed, oops. So our second example that we have listed is negative 9x squared plus 14xy plus 7x squared minus 2xy. So you have a couple options on how you want to organize and rewrite this for yourselves. I'm just going to show you guys another one if you can use either one that you meant. If you're someone who's comfortable with the first method that we had where we rearrange these things and then we combine like terms, you are more than welcome to do that. I will not say no or frown upon you taking that extra line of work to keep it organized for yourself. Go for it. That works for you. But if you can see what is going to be combining together and you can keep track of all that in your head mentally, you're absolutely welcome to do that as well. So I am seeing I have an x squared term, xy term, x squared, and xy term. So I'm going to just look at my xy's first and say I have a negative 9x squared plus 7x squared. So x squared terms, I'm going to have an x squared in my final answer. Negative 9 plus 7 is going to give me a negative 2. Again, the coefficients are the only thing that change when we're combining like terms. The variable parts stay the exact same. I've seen a lot of people with these parts will say, okay, well, negative 9 plus 7 gives me negative 2. And then x squared plus x squared is x to the fourth. And that is inaccurate. We do not change the variable part in any way, shape, or form when we are combining like terms like this. If you are doing that on the homework, if you're doing that on the test, you're going to be losing points. So we've combined our x squared terms, great. We also have xy terms. So they're both xy's. I'm just going to combine the coefficients together, again, the numbers out front. So I have 14 minus 2. That's going to give me a positive 12. And then the variables themselves just come down as they were. The variable part does not change in any way, shape, or form. I'm looking at this problem saying, can I combine anything else? Well, my first term, it has an x in it. The second term has an x in it. So I can combine those together. And no, we can't. Our first term is an x squared term. Our second term is an xy term. So they both have an x in them. Great, accurate. But the variable terms themselves are not in every way, shape, or form identical to one another, so I cannot do anything else to this problem. I have fully simplified it. I am done. Okay, we'll take a look at a couple more. So we're going to have a few more steps in the process that we're going to need to go through with this. So we have 3y plus 2 times the quantity. Whoops. negative 4y. Making sure you're writing down the right problem is important. Plus 3y. Okay, so we've got that there. Now again, we're using PEMDAS for this. We are told to simplify. We just now have our ways of going through and combining like terms at our disposal. So again, starting with PEMDAS, I need to look inside the set of parentheses first, and what can I simplify in there? So again, we have PEMDAS, we go inside a set of parentheses, we restart PEMDAS all over again. So I'm only looking at negative 4y plus 3y. They are like terms, they both have a y with them, so I can combine them together and just add the coefficients. Nothing else is changing. So I have negative 4y plus 3y, so negative 4 plus 3, that's going to give me a negative 1. And we can write that in just as negative y. It is implied that there is a negative 1 in front of that. So we do not need to write anything else. So I'm done with parentheses. So we're good there. I don't have any exponents, so we're good there. Multiplication, division. I've got these two things that are multiplying together. I have 3y plus 2 times negative y, so positive times a negative. Let's just here get the colors right here. Let's keep the color coding accurate. So I have a positive 2 times negative 1. It's going to give me a negative 2. And the y is going to stay there. I have no more multiplication or division going on. I have addition, subtraction. So I'm looking at these two things saying, are they like terms? And they are. The variable parts of these terms are the exact same. So I can add the coefficients together. So 3 minus 2 is just going to give me 1. And I can write my final answer then just as y. You are rarely, if ever, going to see this answer written out as 1y. You're being asked on the homework, fully simplify your answer. You get down to, well, I have 1y as my final answer. They are looking for just y. It is assumed that having just y written down or just an x written down, that there is a coefficient of 1 in front of it. Again, those invisible ones that show up everywhere. We have our final answer there. So I'm going to move us back over here, and we'll go through a few more ones with a few more steps in them. So looking at number 4, which, yeah, and look at number 4, 5, and 6, we got a lot more setup steps we got to do with it. But again, it's PEMDAS. That's telling us exactly what we need to do. It's taking all of the guesswork out of this for us. Again, I highly recommend, if you need to, print that out for yourself, print out the notes about using PEMDAS, write it out for yourself off to the side, whatever is going to help you keep track of where you are and what you're doing next in the problem. All of that is very, very useful. All right, and did I write everything down correctly? Checking my other screen. Okay, looks good. So again, we're using PEMDAS, our order of operations. Now again, you can write it off to the side. I'm a little low on space over here, so keep track of it just by writing things out and detailing it here. So PEMDAS, starting inside my sets of parentheses. I'm going to simplify just inside the parentheses first. That's all I'm doing with my first step. Move this up here a little bit. So look at the first set of parentheses that we have here. We have 5x minus x. The coefficients are the same, which means, or the variable parts are the same, which means I can combine the coefficients together. So I have 5 minus 1. It's going to give me 4. And then the variable stays the exact same. In our second set of parentheses, we have 3xy plus 7xy. The variable parts are the exact same. Great, these are like terms. So I add the coefficients together. 3 plus 7 is going to give me 10. And the variable part is just going to come down as it was. It's not changing at all. Then looking at the last set, I've got x's again. So I have 6x minus 10x. It's going to give me a negative 4x when I do that there. So I've done everything that I can inside my set of parentheses. I think I might be able to have space to write in PEMDAS over here now. Yeah, there we go. Okay, we've got space for this. Excellent. So we've done everything inside the parentheses. We don't have any exponents. Multiplication, we have a bunch of things that are multiplying together here. So let's go through and do that. 3 times 4x, it's going to give me 12x. Oops. I have negative 10 times negative 10 times 10 xy. So it's going to be negative 100 xy. And then for the last one, we have a positive 7 times negative 4x. Positive times a negative is a negative answer. 7 times 4 is going to give me 28. That there. So multiplication, division, done. Addition, subtraction, what can I combine together here? Well, every single term has an x in it, which is great. However, our middle term has an xy attached to it. The other terms that we have are just with x's. So all I can do is combine my first term and my last term together. The xy is going to stay exactly as it is. I cannot do anything about that. Okay. So combining these things together, the x terms, I have 12x minus 28x. If my mental math is correct, we should be getting a negative 16x coming out of that then. Nothing happened to the, oops. Combine these ones together, just highlighting this. Combine those ones together. Nothing happens to the negative 100xy, so it's just going to come down to the next line as it was. No changes whatsoever to it. I cannot combine like terms any further. So I'm done with that part of PEMDAS, and I'm done the overall problem. I've got my final answer. And again, we are perfectly fine with leaving our answer having variables in it. That's, again, to be expected. There's nothing wrong with that. Go on to another one here, just trying to keep track of time. And this part down. We'll separate this out here. So we're going to start seeing ones where we have more exponents showing up, which is what this example has in it. Again, we also need to be very mindful of and keep track of, again, what our main definition of a like term is. We are combining like terms and identifying the variable parts versus the constant parts. Let's do this. All right, I'm just checking to make sure I have everything written down correctly. And yes, I do. Okay. So we're good to go there. Now, again, we're using PEMDAS. We're simplifying. Not much is changing on that front. We look inside each set of parentheses first and say, can I combine like terms here? Can I combine like terms here? Now, the first set of parentheses, which we're looking at on this side, saying 3, what are the variable terms, the variable parts? xy squared, okay, and x squared y. Well, they both have an x, they both have a y, and they both have a squared term in them. The problem is, in the first term in that, the y that's being squared. And the second term, it's the x that's being squared. So these two variable parts are indeed similar to one another, but they are not identical. Remember, the variables need to be the same, and all of the exponents that's attached to each of those variables need to be the exact same. So in the first set of parentheses, I cannot combine anything together. Both have x's, both have y's, great. Exponents are different. Can't do anything else with that. So looking at the second set of parentheses, looking for the same thing. Are the like terms at all? Are the variable parts the exact same? Well, similar to the first one, we have both of them has x, y's. They're x's and y's, but the first one has a y squared, the second one has an x squared. So the variable parts are not the same, which means I cannot combine anything together inside that set of parentheses. So if we're writing out or using PEMDAS for ourselves, which I think now I've got space to write that in here, just off to the side. So in terms of following PEMDAS, I cannot do anything else inside of the parentheses. Exponents, I don't have any other exponents I can work with. Multiplication or division, I can do that. I'm going to apply the distributive property. Each of these, 6 is multiplying through to every single term. -4 is multiplying through to every single term. So I have 6 times 3xy to the second. And I'm just multiplying the coefficients together. That's all I'm doing there. The same thing with the second one in our first term. I have a -4 times -xy squared. Negative times a negative is a positive. And 4 times 1 is just going to give me 4. Better 2. I have -4 distributing through to a 2x squared y. Positive times a negative is going to be a negative. I'm going to have 8 for the number, and then again keep the variables the exact same. So I'm now done with multiplication or division. Good to go there. And now addition and subtraction. So we're applying our properties that we just learned today, combining like terms. I'm trying to find what those like terms are. So I've got an xy squared. Second term isn't that. I have another xy squared, so I can combine those two terms together. And again, when I'm combining like terms, the variable parts stay the exact same. The variable parts stay the exact same. The coefficients are the only ones that are going to be changing when we add those together. So 18 plus 4, that's going to give me 22. And again, the variable part stays the exact same. I'm also looking at seeing, okay, I've got an x squared y and an x squared y here. So I can combine those together. So -18 minus 8, -26. And then just bring down the variable part as it was. It's not changing in any way, shape, or form. And then last but not least, you can do a little bit of rewriting of these things to make sure we have our proper form for our final answer. So if you were going through the problems on the homework and they're saying, well, you have the right thing, but it's arranged incorrectly, something to that effect, because it does show up from time to time. When we are writing out our final answer, make sure you are organizing the terms first by alphabetically, the first letter in the alphabet coming first, and then by descending powers. So what that means is both of these things have an x and y variable in them. So alphabetically, it could go either order in that regard. We go by descending powers, though, by saying, okay, so the first variable that we have with this is an x. So which x has the larger power attached to it? And it's the x squared term. So I'm just going to be rearranging my final answer here. That's all I'm doing. I'm saying the x squared is going to go first. And the y squared is going to follow it. So alphabetical order, and then by descending powers in that alphabetical order. So if you're going through parts on the homework and you're seeing, well, I've done everything correctly, but it doesn't like my final answer. Maybe it says something about syntax form or something in that regard. Does not mean your answer is inherently wrong. You may just need to rewrite it in that regard. So again, that ordering. Whoops, I was erasing that. So first by making it alphabetical, and then by descending powers. So that is everything that we have for today for 3.4 and combining like terms. Again, it's a pretty straightforward process as long as we are taking that extra bit of time for ourselves to make darn sure what our terms are, identifying the variable parts, and then being very methodical with how we go through and add or subtract combine like terms in this regard. And again, I want to emphasize with this, we went through a couple ways of how we can go through these ones. If you're someone who, as you're going to go through these problems, you're going to tell yourself, okay, I need to, at the very beginning, come on, waiting for this thing to catch up to me. If you are someone who needs to rearrange your problem before you combine like terms, that's fine. Do that if you have to. There's nothing wrong with that. If you're someone who can keep track of your work on your own and just can figure out what you combine together mentally and just kind of slow down in your overall process as you go through it in that regard, you don't need to rearrange things, great. You can do that also. I'm pretty indifferent as to which one you guys would like to use and how you want to organize it for yourselves. But just make sure you are keeping your work and your steps organized. The big thing that gets a lot of people in this section and a lot of future sections is thinking, well, this isn't too hard. I can just kind of really quickly skim by and go through it. And as soon as you start rushing yourself, you're going to get errors. So slow down just a little bit, and that might help if you do run into any issues with this on the homework, either for tonight or over the weekend at all. So that's everything for today. I'm going to end the recording, and then if you guys have any questions about things, I'll take those then.